Hello, I'm Barbara Lemisi from Durham University. In the move to a decarbonized energy future, power grid will witness major challenges. On one hand, great deals of uncertainty coming, for example, from the use of renewables, and at the same time, increased complexity if we can imagine 1 million of active devices connected all over the network instead of several tens that it is today. So my research is about delivering a flexible zoning infrastructure to defensively cater for these complexities by efficiently decoupling the big chaotic picture and further exploit the opportunities that a more observable and active distribution is bringing along.
Hello, my name's Pete Reynolds. So I'm just starting my second year at my PhD, and I'm looking at basaltic fissure eruptions. And these are these type of eruptions that you might see in Iceland or Hawaii, where you get a big crack that opens up in the ground and all this lava starts spewing out up in the air. How is this sort of volcanism related to energy? I guess that's the crucial question. How it's related is because about 65 million years ago, when America and Scotland split apart, this was the sort of volcanism that we were seeing, these types of fissure eruptions. And beneath all these lavas, we've discovered oil and gas. So what we need to do is we need to understand the lavas better. We need to understand the type of pyroclastic rocks. That's the sort of bits of lava that are getting shot out through the air. We need to get a better understanding of how these rocks are building up and what sort of reservoirs, what sort of geometries these kind of rocks are forming. And that's I guess that sums it up really. That sums up what I do. I go out and look at rocks.
My name is Ben, and I'm working here in the maths department, and more precisely on statistical methodology. Now the precise sort of more detailed problem is what we call an inverse problem. The forward problem you might think, say you know some properties of the system, what will the system do? The inverse problem will be looking at what the system does and trying to work out what it's like. I'm doing this in the context of climate simulation. So looking at what the climate does and try to work out through the simulator what the climate is like. Now this is a very difficult problem for two main reasons. Firstly, the input space for the simulators is very, very big, and the match between the simulator and the system is sort of, people aren't quite sure how well these two things can match. So it's like looking in a really big space for something and you're not quite sure what it is. So these things make it very difficult to find. The second problem is a more conceptual problem, in that we know that the simulator is wrong, it doesn't obey the same rules as the system, and so we ask ourselves why exactly we should take notice, why exactly we should gamble and make bets on the veracity of the simulator's findings.
Hello, my name is Douglas Halliday, and one of the roles I have here at Durham University is the Director of the CDT. So our Centre for Doctoral Training consists of 40 PhD students who are conducting research right across the energy landscape. So one of the real benefits of the CDT is that we have students from the physics department, chemistry, biology, engineering, computer science, mathematics, anthropology, geography, law. So the CDT provides a very broad disciplinary base for which the students can conduct their research. And one of the great benefits of the CDT is that it provides opportunity for interaction So the students are able to learn about each other's research projects, learn about the problems and challenges they face, and they can work together to provide creative and innovative solutions to the research problems they're working on. One of the other real benefits the CDT provides is the opportunity for the students to gain a much broader range of skills through training, through workshops, through visits to industrial sites. And this film festival, the Durham Energy Futures Film Festival, is an outstanding example of the kind of creative approach that our students take to their work. So I would commend the film festival to you, and I hope you enjoy watching it and that you will go away much better informed about the energy challenges our society faces for the future and the way in which these 40 young, creative and highly intelligent people are working to solve our problems for the future.